This video is the next video in the algebra set of videos, and in this particular video we're going to be looking at factorising quadratic expressions. I follow a 6-step method for factorising quadratic expressions, but this 6-step method is best explained by looking at an example. Therefore, to begin, I'm going to look at example 1.4, part A. Here it says factorise the following expression. The most important thing to note is that an expression in the form ax squared plus bx plus c is what we call a quadratic expression. A quadratic has an x or y or k or some variable squared, and it also has a variable to the power of 1 and a constant. That constant can be 0, but for it to be a quadratic, it needs to include the x squared. This is what we refer to as the general form of a quadratic, where a, b, and c are numbers, and those numbers are any real number. Remember, a real number is any number, so it could be a fraction, a decimal, it could be pi, it could be epsilon. There's any number that you could have there is acceptable. When factorising a quadratic expression, the first thing I do is I write the quadratic in the form ax squared plus bx plus c. It's usually a good idea to write down ax squared plus bx plus c to make sure that the quadratic is also in that form. In this quadratic that I have in example 1.4a, I have x squared plus 10x plus 21. Remember, if I have x squared, that's just like saying I have one apple or an apple. So sometimes mathematicians don't write in the 1, but the number in front of the x squared is 1. Next, I list a, b, and c before I look at the next step. So a here is 1, b is 10, and c is 21. Next, I multiply a by c. And here we can see a by c is 1 by 21. That gives me 21. And then I list the numbers that multiply to get this number. The best way to do this is start with 1. So we have 21 times 1 will give us 21, but also minus 21 times minus 1 will also give us 21. Next, we've divided 21 by 1. If we divide 21 by 2, it won't give us a whole number, so we don't go with that. 21 divided by 3 is 7, so 7 times 3 will give us 21, but also minus 7 times minus 3 will give us 21. 21 can't be divided by 4, or 5, or 6. However, 21 can be divided by 7, and we can see here we already have the 7 involved. 7 times 3 gives us 21, or minus 7 times minus 3 gives us 21. Once you see a number that you're dividing the number by appear in the list already, you usually have enough numbers multiplied by another number to move on to the next step. The next step is circling the option that sums to get the number in front of x. In this particular example, the number in front of x is 10. So we're looking for, in the list that I've written down on the middle of the page here, when we add those numbers together, the answer should be 10. Here we have 21 plus 1, which would give us 22. That's not 10, so we don't choose that one. Minus 21 minus 1 is minus 22, so we're not going to choose that one. 7 and 3 is 10, so we'll choose that one. And as we've now chosen the one, it's not going to be minus 7, minus 3, but that gives us minus 10, so it's not going to be that one anyway. The next thing we do is we rewrite the x term, but we rewrite it with the numbers that we've just chosen. So we'll write x squared plus 7, and we'll write an x after that, plus 3 and an x after that, plus 21. Now, if you see what we've done here, we have 7x and 3x, which is 10x. So we've technically done nothing except split the 10x up into 7x and 3x. Then we underline the first two terms, so the x squared and the 7x, and we underline the second two terms, which is the 3x and the 21. We look at the first two terms, which is x squared and 7x, and we say to ourselves, what can we divide out of both of those? And if you see here, we can divide an x out of both of those, as we have x squared and we have 7x. When we divide an x out of both of those, we'll be left with x plus 7. We then look at 3x and 21. And if you look at 3x and 21, we can factorise a 3 out of both of those. When we factorise 3 out of both, we'll be left with x plus 7. Lastly, we look at what's inside the brackets and what's outside the brackets. If you notice, on inside the brackets, we have x plus 7 and x plus 7. So what we can do is we can factor an x plus 7 out of x plus 7, and 3x plus 7. When we do that, we'll be left with x plus 3 and x plus 7. We've now factorised x squared plus 10x plus 21. To recap the steps involved in factorising a quadratic expression, the first thing we have to do is make sure that the quadratic is written in the form ax squared plus bx plus c. Then I label a, b and c. A here is 1, b is 10, it's the number in front of x, and c is the constant, which is 21. I then multiply a by c, and in this example that's 1 times 21. That gives us an answer of 21. And next we need to figure out the numbers that when multiplied will give us 21. Begin by dividing the number by 1, 2, 3, 4, 5, up until you can't divide it by any other number. We did that here. And what you have to do then is you look at all the numbers that you've found and you choose the ones that when you add them together give you the number in the middle, which is the x. So in this case, we were looking for the one that gave us 10. When we choose that, what we do is we rewrite the quadratic with the middle term, which is the x, replaced with what we've decided adds up to give us that term. So in this case, the 7 and the 3. We then underline the first two terms and the second two terms. We factorise them. If we've done this correctly, we should be able to factorise the remaining expression to give us two brackets, one with an x plus one number and one with an x plus another number. Part B, we're going to factorise the expression x squared minus 5x plus 6. Again, this is written in the form ax squared plus bx plus c. I'm going to label a, b and c. Here, my a is equal to the number in front of x squared, which here is 1. My b is the number in front of x, which is minus 5, ensuring that you always take the negative number. And c is positive 6, so we can write 6. I then multiply a by c, and a by c is 1 times 6. That will give us 6. Next, we need to list out all the numbers that multiply to get the number. Again, start with dividing it by 1. 6 divided by 1 will give us 6. So 6 multiplied by 1 will give us 6, but also minus 6 times minus 1 will give us 6. Next, divided by 2. 6 divided by 2 will give us 3. So 3 times 2 will give us 6. But also minus 3 times minus 2 will give us 6. 6 divided by 3 will give us 2. And we've already written that example there. So now we've written all of the things that can be multiplied to give us 6. We then choose the ones that add up to give us b. And here, going through them, 6 and 1 will give us 7, so it's not that one. Minus 6 minus 1 will give us minus 7, so it's not those two numbers. 3 and 2 will give us 5, so we're nearly at 5, but we need a minus 5. So minus 3 minus 2 will give us minus 5, so we're going to pick those two numbers. Then we rewrite the quadratic, so x squared. But we're going to replace the bx with the numbers that we found. So we have minus 3x and minus 2x. And then the c stays exactly the way it is. It doesn't matter what order you put these in either. So for example, I could have written x squared minus 2x minus 3x plus 6. Then you underline the first two terms. And you underline the second two terms. Looking at the first two terms, we have x squared and minus 3x. Here we can divide out an x from both terms, leaving us with x minus 3. And the second two terms, we have minus 2x plus 6, and from them we can divide a minus 2. That will leave us with x minus 3. Looking at the brackets, we can see in the inside of the bracket we have x minus 3 and x minus 3, meaning we can factorize an x minus 3 out of x minus 3, minus 2, x minus 3. That will leave us with x minus 3 times x minus 2. And we've now factorized the expression. In part C, we've been asked to factorize the expression 6x squared plus x minus 22. Again, we need to make sure that the quadratic is in the form ax squared plus bx plus c. I'm going to label a, b, and c here. A is 6, b is 1, and c is minus 22. And again, ensuring that you always bring the negative sign. Next then I multiply a by c, which in this case is 6 multiplied by minus 22. That gives us an answer of minus 132. Now a lot of people get freaked out when they get a big number here, but don't freak out, just take your time and do it the exact same way. Again, what you're going to do is you're going to figure out the numbers that can divide into 132. We start with 1, and that will give us the answer of minus 1 times 132, or 1 times minus 132. Again, remember, we need the answer of minus 132 for this one. Next, we try 2, so minus 132 divided by 2 will give us 66. So we'll have minus 2 times 66, or 2 times minus 66. Again, divided by 3 next, which gives us 44. So we have minus 3 times 44, or 3 times minus 44. Next, we can try 4. When we divide it by 4, we get 33. So we'll have minus 4 times 33, or 4 times minus 33. Divide it by 5, and it won't divide in evenly. But if we divide it by 6, it will divide evenly in and give us 22. So we can have minus 6 times 22, or 6 times minus 22. When we divide it by 7, we don't get an even number. When we divide it by 8, we don't. When we divide it by 9, we don't. When we divide it by 10, we don't. By 11, we do. So 132 divided by 11 will give us 12. So we get minus 11 times 12, or 11 times minus 12. Next, we divide it by 12, and 132 divided by 12 will give us 11. So once we start making our way around and seeing numbers we've seen before, we should have the answer in front of us. Now we check our answer. So we're looking for b, and b is 1. So minus 1 plus 132 is definitely not 1, so it's not that one, nor is it the second, or the third, or the fourth, as none of them when added together will give you 1. The same with all of the ones on the left-hand side, and with minus 6 plus 22 and 6 minus 22. When we arrive at minus 11 plus 12, that will give us 1, which we're looking for, and 11 minus 12 is minus 1. So we found the one that we're going to use. We're going to use minus 11 and 12. So we can rewrite the quadratic as 6x squared plus 12x minus 11x minus 22. Now we underline the first two terms, or group the first two terms, and also group the second two terms. We say to ourselves, what can we divide out of 6x squared and 12x? Well, we can divide 6x out of those, and we'll be left with x plus 2. And then we say to ourselves, what can we divide out of minus 11x and minus 22? Well, we can divide a minus 11, and we'll be left with x plus 2. Now that we have the inside guys being the same, we can divide both by x plus 2, leaving us with x plus 2 times 6x minus 11. Now, once we've got that done, we've factorised the quadratic 6x squared plus x minus 22. Once you follow the 6 steps, you'll be able to factorise any quadratic expression that you get. The most important thing is you have it in the form ax squared plus bx plus c. Always label a, b and c to ensure you're not going to make any mistakes. Multiply a by c. Find the numbers that multiply to get the number you got when multiplied a by c, and choose the numbers that when added together will give you b. Rewrite the quadratic with those numbers in place of b with x's or y's, whatever the unknown is or the variable. Factorize the first two terms and the second two terms, and then you should be able to factorize again after that. And if you can, you've done it correctly. Factorizing is absolutely everywhere on the Junior Cert and on the Leaving Cert exams, so it's really important that you're confident at doing this. It's important that you spend a bit of time trying a few of these questions, and if you find them still difficult, you must let me know so that I can go through some with you. But that brings this video to an end, which was all about factorising quadratic expressions.